Good afternoon, everyone. Today we're going to look at why is x to the power of 0 equal to 1 for any value of x, which is to say, why is any number to the power of 0 always equal to 1? Now, the real answer lies in set theory, which is a branch of advanced mathematics at UT University, but for now we can kind of get a decent answer by looking at the patterns of exponents, okay? So let's start off with one that most of us are familiar with. Let's start with powers of 2, okay? If we start with 2 to the power of 5, let's say, if I ask you to evaluate 2 to the power of 5, you'll find a value of 32. Next, we have 2 to the power of 4, which is equal to 16. Next, 2 to the power of 3, we have 8. For those of you that are familiar with exponents, grade 9 students and above, this is something you've seen before. Then 2 to the power of 2, we have 4. And so I'll make a note that what's going on in this pattern, very clearly, is that every time our exponent drops down by 1, so our exponent decreases by 1, our value gets divided by a factor of 2, right? That's what it means. We get one less factor of 2, and so to go from 2 to the power of 5 to the power of 4 is the same as dividing our answer by 2. So again, as the exponent drops down by 1, our value drops down by a factor of 2, which makes sense if we understand how exponents work. And so if we continue this pattern, 2 to the power of 1 is simply 2. And so again, as the exponent drops down by 1, our value decreases by a factor of 2. And if we go one exponent further, what we'll have is 2 to the power of 0. Now, 2 to the power of 1 is easy enough to explain to someone who's never seen exponents before. It simply means 2 times itself once, which is just 2. Likewise, 2 squared, 2 to the power of 2 means 2 times itself 2 times, 2 times itself 3 times, and so it's easy to explain how factors are written out in a more traditional sense. 2 to the power of 0 is tricky to explain in the traditional exponential sense, okay? But if we do continue this pattern, we still drop our exponent down by 1, and so it should continue that the value should decrease by a factor of 2. And that is exactly what happens, okay? And so looking at a pattern like this does suggest that 2 to the power of 0 is equal to 1 could be applied to any base with similar exponentials. And we would see a similar pattern, right? If we kept going, if we have 2 to the negative 1, if we want to go one further into negative exponents, so dropping our negative again by, dropping our exponent by 1 more, for those of you that have seen exponents, 2 to the negative 1 is simply written as 1 over 2 to the positive 1. The negative of the exponent simply flips, and so 1 over 2 to the positive 1 is simply 1 over 2. And so 2 to the negative 1 is 1 over 2, which would still continue the pattern of our values decreasing by a factor of 2. And so this is one pattern. Now maybe 2 is just unique in this way. Well, let's explore something else. Let's explore the base of 3. So we have 3 to the power of 5, that is 243. 3 to the power of 4, we have 81. 3 to the power of 3, we have 27. 3 to the power of 2, we have 9. 3 to the power of 1, we have 3. And so if we look at our patterns in similar ways, we see the exponent continues to drop down by 1 at a time, and that our values analogously decrease by now a factor of 3, since our base is 3. And so, if we're bold enough to go down to 3 to the power of 0 once more, 3 divided by 3 brings us again to 1. So we get a second example of when a base x to the power of 0 is equal to 1, because our pattern should continue if our pattern is well constructed. And so we get another case where we have some base to the power of 0 is equal to 1, okay? And it turns out that this is true for all values of x, even 0 to the power of 0 is equal to 1. And it has something to do with set theory. For those of you that are interested in stuff like this, you can look at set theory on Google, or there are a number of great websites. And it has to do with the empty set, namely that We don't say that there are 0 elements in an empty set. So if I give you a set of elements and there's nothing in it, for example, if I give you a set with the numbers 1 and 2, the number of elements in the set is 2, right? 2 elements, which would be analogous to writing 3 to the power of 2, because we would have this can be written as 3 times 3. We can think of this as a set with 2 elements. And a set with 2 elements, we count as a set with 2 elements. A set with 0 elements, we don't count as a set with 0 elements. We count it as the empty set because it's a universal idea that is embedded deeply in set theory that I can't really explain in this video in exponents, but if you're interested, I really encourage you guys to watch it. It is interesting, it is advanced, so I'll leave that up to you. But in any case, hopefully this kind of gives you a reasonable idea as to why any number base to the power of 0 produces a value of 1, okay? So, I hope this helps. If you guys have any comments, any questions, suggestions for future videos, please let me know in the comments below, and thanks for watching.